Have you noticed that all of you can deduce the electron configuration of any element if you have a periodic table? You don't even have to learn the names or the number of periods or even the Aufbau chart. You have all you need in the periodic table. But how? Let's see. If you have a periodic table, you know that this corresponds to the S block, right? This one corresponds to the P block. This one in the middle is D block. And here at the bottom, you have the F block. What else do you need? The level of energy, right? And you know this is level 1, 2, 3, 4, 5, 6, and 7. You have the levels. What else do you need? There are two keys you need to learn. In the period, when you need to write the level of energy, you need to subtract 1. It means you have 4 here. Let's say you have 4 here for this period. But if you enter to the D block, it should be 3. Instead 4, this should be 3. And another rule, if you enter the F block, which is right here in the bottom, you will subtract 2, not only 1. Let's do some exercises together. Work with me. Let's do together, let's say carbon. I'm pointing it here. Yes, we have carbon here. So carbon has 6 electrons, right? Because the number of the atomic number is 6. So I write 6 carbon. I will begin writing the first level of energy. Notice that we are going to name every block, every box where we are passing through. We will always begin with in here. 1, S, this is S1, and remember that this is S2, right? So we begin with 1, S, because this is S block, and although helium is here, is S2. So 1, S2. Let's continue. What's the name of this box? 2, S2, right? This is called 2S2. 2S2. And now, what's the name of this? 2P. Now I'm moving to P block. So it's 2P2 because it's in the second box. 2P2. 2P2. And that's it. We have finished. Let's do another one together. What about potassium in here? Potassium has 19 electrons because the atomic number is 19. So let's begin again. Let's name the first row. 1s2. 1s2. Let's move to the second row. 2s2. And we are here. 2s2. Now move. We are here. Let's move all the way until here. This is 2, block P, 2P, 1, 2, 3, 4, 5, 6, 2P6. And we write it, 2P6. Now, next level. Which level is it? This is 3. 3, S block, 2. 3s2. 3s2. What's the name of this? 3p6 until the end, right? 3p6. And now we just need to name this one, potassium. What would be the name of this last level? 4, right? S, because this is in S block, 4S1. Very good. Now look, can we also deduce kernel configuration from the from the periodic table? Of course we can. Watch what I'm going to do. Let's do the same potassium in here. Which is the previous noble gas if we are trying to do potassium? The previous will be argon, right? And remember that for kernel, we always use the last noble gas. So, how should I write this? I will write this way. We are again going to do potassium, but now we are going to do the kernel one. So we write argon, which is the previous, it is here. It is the previous noble gas, argon with atomic number 18, and then I just need to finish what is next, argon. What is it next? It is 4 is 1. 4 is 1. And that's it. If you want to do this the way we've been doing this in class, you will see that this configuration belongs to argon. Remember, we call these the core electrons. And just the last name is this part, 1 valence electron. Located where? In the 4th level of energy. Do you want us to do another one? Okay, now you try by yourself. Well, you know what? You know what? Now we are going to do a different one. Let's do, hold on. I'm trying to erase this to have some space. Okay, now I want to do, let's try vanadium. Look, vanadium is just here, right? So it's vanadium, which atomic number is 23. Let's do the kernel one. Again, the previous noble gas is argon. So I will write inside square brackets noble gas argon. And then what's next? Let's continue here. 4s2. 4s2. And here is the tricky part. Pay attention. As soon as you get into the D block, you need to subtract 1. So instead, the name of this is 4D, it is 3D. 3, because we are subtracting 1 from this 4. D, because it's in D block. 3, because it's the third box. 1, 2, 3. So it's 3D3. How are you feeling with this?